a day or two later. So by then, lactate is normal. Lactate is not causing the soreness. The soreness is coming from, you have this mechanical damage inside the muscle, and then in response to any kind of damage, what do we get? Inflammation. And we sense that soreness in response to the inflammation. Right? We have an influx of white blood cells to start the healing process. Lactate is your friend. So there's a lot of good things that lactate does. We need to have lactate accumulate in the muscle. It supports the continued production of ATP from glycolysis. We need lactate to be produced to keep fluxing through the chemical reactions of glycolysis. It's also used as a fuel by the heart. Lactate, when it's accumulated in the muscle, it gets transported places. One place it gets transported to is the heart, so the heart can use it as a fuel. It's used by the liver to make new glucose. And that's a fancy term, gluconeogenesis. Neo meaning new, genesis, the formation of. Because muscles prefer to use carbohydrate, but we only have a limited store, when we start to run out of muscle carbohydrate and blood glucose gets low, that's threatening to the survival of your muscle. And so your liver senses that. Your liver senses that, oh no, the carbohydrate fuel tank is getting low. And it will take things that are not glucose, lactate, and amino acids, and it'll convert it into glucose. How cool is that? Imagine if your car did that. Imagine if you're driving down the highway and your gas tank starts to run really low, and there's a part of your car that senses that, let's say the engine. And when your engine senses that your gas tank is getting low, it will take another part of your car, let's say the back seat, and it'll turn the back seat into more gasoline so you can keep driving down the highway. That's what your liver does. You have a really smart liver. How cool is that? Because it's threatening to the survival of your muscles to run low on sugar. Gluconeogenesis. Thanks, liver. And then we can go back up the steps.